All right, now we're going to talk about the segments of secants. A secant segment, and we remember that a secant is a line that passes through a circle intersecting it at 2 points. A secant segment is going to be this entire, from the edge of the circle at point B all the way to E. Also, we will have one from C to E. So let's write down our secant segment here. And let's write this other one down here. And the secant segment will have an external segment to it. And that's a portion like right here, EA, that is outside the circle. So let's write down EA. Now let's get back to our original color. EA. And that is our external segment. And then for our bottom secant segment, ED is our external segment. So here are our external segments. And here are our secant segments. Why is this important to us? Well, what we're going to find out is that our external segment times the entire segment for one segment is going to equal the external segment times the entire segment for both when they meet at a common point. So let's look at an example. All right, so here we have two secant segments, RT and RP, that meet at point R. So that means that our S, our external segment, times RT, our entire segment, is going to be equal to RQ times RP, our entire segment. So let's just go ahead and put in our figures. So RQ is 4. We're going to substitute 4 for RQ times RP. Well, RP is RQ plus QP, so it's 4 plus 5. So let's do the same thing for RT. Let's substitute. RS is 3 times 3 plus X. Give a little bit more room here. So 3 times 3 is 9, plus 3 times X is 3X. And that's going to equal 4 plus 5 is 9, times 4 is 36. So we'll subtract 9 from both sides. 3x equals 27, so x equals 9. All right, so let's look at a little more complicated one. And let's do this one. Actually, let's stick with our same color scheme. So segment AB times the entire segment AC is going to be equal to AE times AD. And it's good to write it out this way and then substitute to help keep you track of where everybody belongs. So AE is x plus 1, and we're going to multiply that times AD, which is x plus 1 plus x minus 1. And that's going to be equal to AB, which is 3, times AC, which is 3 plus x plus 2. 3 plus x plus 2. All right, now let's switch to green here. So first thing, let's combine like terms. So x plus 1 times 2x plus 1 minus 1 is just 2x. So it's going to equal 3 times x plus 5. Let's go ahead and distribute our x's and multiply everything out. We're going to have 2x squared plus 2x equals 3x plus 15. Well, let's move this, let's put our x's together, first of all. These cancel. We end up with 2x squared equals x plus 15. Now I recognize here we're going to have to factor. And when we factor, we need an entire set. We need to set the entire formula to 0. So we're going to subtract 2x squared from both sides. We're going to have 0 equals negative 2x squared plus x plus 15. Now we have some heavy-duty factoring to do. And if you recall from our factoring review that we need to get a plus b that equals the coefficient here, which is 1. And then we have a times b, which has to equal the coefficient here times the coefficient here, negative 30. So what's going to get us there? Well, if this is negative, I know that one of the numbers has to be negative and one of them has to be positive. This is 1, a positive number, so the positive number has to be the bigger number. So let's go through the factors of 30 that will get us to a negative 30 but 1. So what are our first factors? Well, we got minus 1 and 30. We have minus 2 and 15. Minus 1 and 30, when I add them together, is 29, so we know it's not that. 2 and 15 equals 13. We're going in the right direction, but we know it's not that. Minus 3 and 10 is 7. 4 doesn't go into 30 evenly, but minus 5 and 6 equals 1. So those are our factors. So let's plug in 5 and 6 here in x. So we're going to have negative, let's go back to green for this, negative 2x squared minus 5x plus 6x plus 15. So if I were to combine my like terms, minus 5x and 6x, I would have plus x. So we still have the same formula. And this equals 0. But we're not done yet because we still have to solve for x. Well, let's group these. Let's group these and see if we can't find some common factors. So if we group these, negative 2x squared minus 5x, well, they both have an x that I can factor out. An x, and I can actually factor out a negative x, make them positive. 6x plus 15, well, there 3 goes into both of those factors. So I can factor out a 3, and we end up with 2x plus 5. Let's clean up my... Well, 2x plus 5 and 2x plus 5 are the same. So negative x times 2x plus 5 plus 3 times 2x plus 5 is the same as writing minus x plus 3 times 2x plus 5. Well, I can set each one of those individually for 0, and solve for x. So negative x plus 3 equals 0. So we're going to subtract 3 from both sides. And we're going to end up with negative x equals negative 3. So x equals 3. Let's look at the other one. Here we have 2x plus 5 equals 0. I'm going to subtract 5 to get the x's by themselves. That cancels. 2x equals negative 5. Divide both sides by 2. X equals negative 5 halves. And since up here we are looking for a distance, x has to be positive. So there is our answer.